Okay, thank you very much. All right, so welcome to our session this morning. Sorry for the brief delay as we got started. Hopefully everybody can hear me. And so I'm asking that if you can raise your hand which is the 1, 2, 3, 4, 5th column under the attendees section. There's a couple of people that have raised their hands already and indicate that you can hear me, and that's fine. Looks like we have a quorum of people who can hear me. So to answer a couple of questions that always come up during these presentations, slides will be available either after or actually during the meeting. So there may be some that are available or will be available soon, and there will be a recording of this particular session as well, and the WebH folks will figure out how to get that to you. My name is J.D. Baker. I'm a software and systems engineering consultant with specific interest in model-based development. And it is my pleasure to present to you today if I can get this thing work, yes, our webinar on domain-driven design and how domain-driven design maps or is useful in the development of microservices. So we will start by answering a couple of simple questions. What do we mean by domain-driven design? What do we mean by microservices? Like many of the other topics and things that we run into in our day, there is a difference that people feel when they read that word. They mean different things at different times, and that falls right into the notion of domain-driven design and being able to come up with a common definitions for terms, etc. We'll look at the domain-driven design models. They break up into a couple of different major sections, and we'll look at each one. And then we'll use those models and map to different microservice architecture and elements. So we'll sit back and see how we go. So there are a number of definitions here that we need to consider. One of them is that it's a set of principles that we employ on building software, and it's a set of principles that intentionally integrate our domain experts, subject matter experts, business experts, etc., and the software practitioners, so that we can ensure that we align those business needs with IT design and development, and we deliver, as software developers, we deliver what it is that the business needs to solve their business problems. Now, the other thing that domain-driven design is, beyond a set of principles, is a set of tools or models that you use to design and implement that software, and to ensure that the software that you do deliver has a significant value to the business. So we'll come back to microservices, but since it's in the title, I wanted to make sure that we at least defined it up front. Okay, and so a couple of definitions here is that it's an architectural style, and that style is predicated upon the notion of loose coupling. Right, so that each one of them, each one of the microservices that we develop provides some business capability, and they are loosely coupled such that they can be swapped in and out as necessary without causing disruption to the overall business services. So in addition to being that architectural style, it's a method, and it's a method that focuses on that notion of signal functions. So it's the old adage of do something well and don't do anything that's not a part of what you need to do. And do that in cooperation with other services using the notion of interfaces and a well-specified set of operations that you're going to go incorporate. So independent services that communicate over well-defined APIs is a good summary of what it is that we're trying to accomplish. So I want to mention a couple of things that domain-driven design is not. Okay, and there's a list here. It starts with it's not data modeling. Okay, it's not object-oriented modeling. It's not creating a single model for an entire enterprise or organization. It certainly has no dependencies or specifications related to technology or even implementation. And it is, although it's concerned with persistence, the method of that persistence is not important. And in fact, there's a specific set of models that we use to ensure that the whole notion of the repository for our data is abstracted from the actual implementation of it. So the concepts listed, are not directly related because DDD in many cases has something to say about where these things should fit. But it's not the same as OO modeling, although you might use OO modeling in order to do the implementation. So it's more than this, and it incorporates some or all of this stuff. But DDD is not about these particular topics. On the same token, microservices are not, right? So things that microservices are not include they are not a simple API to some complex service in a monolithic application. You may have a microservice that needs to communicate with a legacy app that serves as some sort of a monolithic application. And so we will briefly touch upon what kinds of things that you might do there. But a microservice is not that simply a translation layer that accesses those complex services. It's not a service that has dependencies on its peers that prevent it from being changed and updated independently. What does that mean? Well, that means that I can plug and unplug a microservice at will, and as long as the API doesn't change, the updating of those can happen independently. Now, there are some exceptions to that, and we'll actually cover some of those when we go through the mappings that we do in DDD, and you'll see how that applies to the microservices as well. So it's not a bunch of stuff that's all just packaged up in a Docker container, and because it's in a Docker container, we call it a microservice. Docker containers can have lots of stuff in it, although they're a popular way to deploy a microservice. Just because you're in a container doesn't mean that you're a microservice. And beware of vendors who try to give you microservices, but you don't have any say on how they're deployed or managed or implemented. If you don't have some kind of control over the deployment and management of those microservices, then you're just basically locked into something that may or may not serve your purposes. All right. So to go back to our domain-driven design, there are actually three significant things that we need to consider as we're doing our and following the practices of domain-driven design. The first of these things is the ubiquitous language. Right? So business and dev working together to define a common language for describing and implementing a solution to a business need. Right? So the solution takes on the characteristics of the business when we have input from those subject matter experts and input from the various business stakeholders. So the ubiquitous language leads us to some strategic design, and strategic design focuses on the problem space, right? So the problem domain and what we call bounded context and the context maps. We'll cover those in a little bit of detail as we move through those. But there's a focus on the problem space when we're doing strategic design. On the other hand, tactical design is about solution space artifacts, various objects that you use when developing an application to ensure that the solution is a fit for the problem we're trying to solve. Right? So it is, although it has the kind of the appearance of waterfall in this slide, it is not mandated to be waterfallish. And in fact, once we have the strategic design, and you see some of the things that, the services and the smart UI and the, all of those kinds of things, then we might very well implement one and come back and start over again. And each one of the contexts that we develop that might result in a microservice are informed by their own ubiquitous language. And we'll see a little bit about what that means here going forward. So ubiquitous means everywhere, or permeating everything, or found or appearing everywhere at the same time. And in the world of domain-driven design, it has this notion of structured around the domain model, and something that is understood by both system designers, domain experts, users, developers, anyone who is a part of the team that is developing the software for that particular element should understand what's in the ubiquitous language. How do you document the ubiquitous language? We will talk about that in just a second, but it has to be somewhere where all of the subject matter experts, the business users, the development team, and anyone who's doing documentation or creating diagrams or writing code, everywhere means everywhere in this particular situation. So how do I capture it? Well, first of all, there's some negotiation that has to go on. There's some kind of a meeting, some kind of a grouping thing that says, okay, well, here's what I think the business needs, or here's what I think the business does, and then we can go through that description, whether it be in writing or it be verbally in a meeting or over a WebEx or a go-to meeting like this one, or something of that nature. But in those discussions, we highlight the terminology that's used by that domain or subject matter expert as they describe either the to-be day-to-day operations or the as-is day-to-day operations, depending on what we're trying to develop based on our business needs. And so we have a simple example of what we do with a pizza business. And so there's two ways to take orders, and orders consist of at least one pizza and maybe something to drink and maybe a salad, and we put it out, we write it down, we give it to the cooks. The cooks get the order ready, calculate some totals, and take some money from the customer. So when we look at that particular piece of text, okay, there are things that are emphasized there. That's a discussion that's not very technical, and so we need to start to capture the things that are most important from that ubiquitous language. All right. So the first thing is we get this notion of a word cloud, okay, and literally putting it into a word cloud generator makes the things that are most often repeated or most often stated show up in larger fonts than other things, and so there's some notion of salad's not really important, but order seems to be pretty important, and customer seems to be pretty important, right? So when we look at this, all right, some of these words, they represent objects. So customer, pie, order, all of those things are objects or things in our problem space. Other words represent processes, right? So cook, for example, is a process. We cook a pie, we deliver a pie, we take money. The issue that we run into as we go to capture this language now is that there are some things that represent both objects and processes. Right? So for example, order could mean taking an order, or it could be a thing that is a customer's order. Cook could mean cooking a pizza pie, or the person who cooks the pizza pie. So one of our purposes in developing this ubiquitous language is to ensure that we flush out some of that kind of ambiguity. And we do that through simple questioning kinds of things. We say, well, can I use prepare instead of cook when I'm talking about a process? And we can agree that therefore when I use the word cook, it is the person then that prepares the pie, and we get some agreement out of that. We start to ask questions about, well, we seem to have two words that mean the same thing. Is it pizza or is it pie? And can we generalize any of the items that we saw in the text, such as, can I call a pizza, a soda, and a salad all order items, right? So that I can do some generalization of those things. So then we ask the question of, well, the system that we're going to be developing, is it only meant to manage orders, or is there some payment or delivery management that needs to take place as well? And as we go through this information and dig it out and flesh it out, it may wind up being multiple meetings. This 3 slides is is a pretty simple kind of example here, but it may take us a while to go through, gather up the information, document it, and then come back and make sure that that we understand what we documented, and ask the questions that have arisen as we were creating the documentation. The documentation could be as simple as a glossary, a dictionary kind of thing. I like to use some tooling in this respect, rather than simple Word or Excel spreadsheets or something like that. And so it's either doing something with a modeling tool, or perhaps doing something with a wiki, so that it can we can start to capture things when people see things that are missing or wrong. They can fix them or add them, and you know, if the fix is incorrect, most wikis have the ability to roll back. So it happens to be one of my favorite kind of documenting tools. You can kind of mix the process with the outcome, with the artifacts, and capture it all in one place. And everybody knows where to go. Everybody's got a browser, so we can quite simply go through and do the editing kinds of things that we need to do to capture that ubiquitous language. And now everybody knows where to go look. When I say cook, what does it mean? Well, I can go to the ubiquitous language documentation and find out exactly what it means to be a cook. So when we talk about domain experts and problem space domains and other kinds of things, when we talk about a business domain, it could be any one of the things that we see on this list. We see things that are an entire industry, things that are a specific company, or parts of a company, such as the human resources department or the warehouse, or even something as simple as a process like the scheduling process. When we talk about a business domain, the business domain is always something that is defined by or bounded by the terms of the ubiquitous language. That's a somewhat recursive definition, but the language of the definition, the language of the domain has to come from the domain experts, and the domain has to be bounded by the ubiquitous language. And so we may be calling it one thing at the start and realize that we have something different. You know, we may be working on things that when as we create our definitions, we realize, you know, are outside of what we thought our domain was, and then we need to consider, you know, is that because they really are outside, or because we're, you know, we have a somewhat of a fuzzy definition, a fuzzy bound. The end of the definition of the ubiquitous language should be a somewhat firm set of boundaries around each of our business domains. So in DDD, we talk about things like the problem domain. So that's the problem that we're trying to create a solution for. And then when we talk about the domains in our strategic model, we talk about things as being either a core domain or a subdomain. Right? So a core domain is essentially a company's key domain. That's the things that they must do well. That's the things that are part of their business, and therefore probably should not be outsourced. And so, for example, our pizza business would be, you know, our core domain would be pizza creation and pizza development, or pizza preparation and delivery. And although our business will include some form of accounting or human resources, they are not our core domain. Those are things that we would consider to be a subdomain. So, for example, accounting and human resources one way. Another kind of subdomain is a kind of decomposition of our core domain. And so if e-commerce was our core domain, shipping and billing might be separate subdomains that are a part of or related to our core domain. It's important to be able to define what that core domain is and therefore create that ubiquitous language around there. Because as we'll see, when we start to create subdomains, there may be some overlap between shipping and billing as far as language goes, and we'll have to deal with that overlap. We'll have to to realize that I perhaps need a different set of information about customers when I'm doing shipping than when I'm doing billing. So the shippers don't have to know anything about the creditworthiness of a customer, but the billing might need to know something about. So they both have customers, but they're different kinds of, or different descriptions, or different definitions of exactly what a customer is. So we have, let's say we have a bookseller, right? Somebody that has a brick and mortar operation that sells books. Their core domain would be, the bookseller domain, right? And then we decompose that and say, well, all of these things are important aspects of bookseller. They're not the whole thing, right? So we break the core domain down into multiple subdomains. And so we have customer management, book ordering, store operations, retail management, inventory, and employee management. So these are all a set of subdomains, and as we'll see, they will all be addressed independently as a part of our development effort. And overall, then we can prioritize which one of these subdomains are going to be developed first. We can set up some sort of a product backlog that says how we're going to address these, etc. So we can fit them into whatever our development process is, based on the fact that I now have a reasonably good definition of what store operations is, and beyond just the notes that you see here, there will be additional information along with that ubiquitous language that tells me what kinds of information are addressed in store operations, which is going to have a different ubiquitous language than the book ordering subdomain, which will again be different than customer management subdomain. There may be some overlaps. There may be some things that we need to consider with respect to how do we share stuff, etc. We'll actually look at a brief example of that going forward, or we might figure out how to create separate sets of information for each of those subdomains. Alternatively, I have a core domain of pizza making, okay, that's in my pizza company. And because it's a business, I have to do some accounting, and because I have employees, I have to have some sort of resources, right? But the things I have to excel at are making pizza, and perhaps delivering pizza, and getting hot, good tasting product in the hands of the customer in a timely manner is probably something I have to excel at, or I won't be in business for very long. So I need to be really good at pizza making. I need to be okay at accounting, right, and human resources, but a lot of that is I now have some decisions to make. I don't have to develop my own human resources information, okay? I might outsource that to a company like ADP, or I might make some an in-house development decision. But the fact is that each of these subdomains can be developed independently and may well be independent in terms of somebody else doing it instead of me. So as we talk about our the grouping of things and the mapping of our domains to various implementation and moving down the strategic design approach, we need to talk about context. An important concept in DDD is this notion of bounded context. And that's where we get our solutions to the problems described in the subdomain. So we're in the subdomain, we're describing our problem. In our bounded context, we're solving that problem. Right? And so the context in general is this set of conditions in which something exists or operates. And for our purposes, that in that general definition, that something refers to the software system that we're trying to develop. In our domain-driven design, context refers to the solution space or the solution domain. Right? So we have a set of what we need described in the domain, and then a set of how we're going to do that, how we're going to solve the problem is described within the bounded context. Now, one of the things that we're talking about a couple of times already, I may have mentioned, is this word model, okay? Eric Evans wrote the initial book on domain-driven design back in 2004, and he defined a model as a system of abstractions that describes selected aspects of a domain and can be used to solve problems related to that domain. So one of the key characteristics of a model is it's not exhaustive, right? It contains the key characteristics or the selected aspects of what I need to know, the most important stuff, and the solution can be derived from that set of abstractions or definitions, etc. Now, when I say models to most people, they start to think in terms of modeling languages that are graphical. So they think in terms of pictures or diagrams, and they look at models in that respect. However, a model could be text. A model could even be code. Right? And so there are mappings in the most case from various kinds of diagramming techniques to various kinds of coding techniques. And so intentionally, the domain-driven design folks, if you will, the people that are writing the books and starting with Eric Evans, have intentionally not provided a modeling language for domain-driven design models. In fact, most of them intentionally do things that don't look very professional or finished, or they want to imply that things are not set in concrete, that these things are adjustable, etc. There are some people who have done some things with UML, and so for those of you that are familiar with UML, you'll notice that that some of my early diagrams were actually UML packages that have been defined as core domains or subdomains, and there's a couple of us that are working on a way to create what UML calls a profile for domain-driven design. That is that each of the characteristics of both strategic and tactical design will be a specialized UML element, and then we'll create some diagrams from that. Free-form diagrams are also possible, and many people like to work with simple circles and lines and do it that way. One key characteristic of these models, one thing to keep in mind is that the diagrams need to be consistent to be understood by all stakeholders. And so if you use a circle in one diagram, you should use a circle in another diagram, right? And that the legends for all of your diagrams should be part of the ubiquitous language of the model. And so the Software Engineering Institute, when they talk about documenting software architectures, offers the suggestion that if you're not using a standard modeling language, that you should always have some kind of legend for every kind of diagram that you create. Right? That advice is good advice for domain-driven design as well, as long as you are using the notion of some kind of relatively free-form diagrams and free-form drawings. So strategic design, okay, takes the stuff that we're doing in the problem space, the definitions, okay, and we want to align our design model with the domain model. Right? We'd like to divide those monolithic domain models into ones that represent subdomains. Right? There are a number of issues with trying to represent too big of a chunk of an organization or an industry, et cetera. And one of those is simply that there's a difference in meaning in some of the nomenclature that we use. And so the language is different, not in the words that we use, but in the meaning and the intention of those words. So the strategic design recognizes the fact that we have this potential collision, and there are concepts that help us manage these differences. And so we're going to talk some about the bounded context, and then we're going to talk about a context map. That is, how are those bounded contexts related to a subdomain, and how are those bounded contexts related to one another as we go forward in solving the problem. So if you start with the whole business, okay, then you're going to wind up naturally with multiple concerns. And in fact, some of those concerns will not be related to anything else. Okay, so as we work through, we need to identify what those concerns are, and then make them more manageable by creating the subdomains. All right, so each subdomain should focus on an individual separate concern. Right, this is still a problem space activity, so a subdomain should be focus on a problem space concern. That is something that the subject matter experts, the domain experts, the business users, wherever you are in your organization, separating out those subdomains is definitely a problem space concern. But how I map those to a solution is a solution space concern. How I map the solution elements that are going to implement or create the solution for a particular subdomain is something that is a solution space concern. Right? What I should expect is that each of the separate concerns may have some kind of relationship or dependency on other concerns. Right? And that's something I should be aware of, but I suggest that trying to define the connection between subdomains at the same time as you're trying to separate them out and figure out what goes with what, that can cause a problem if you're trying to create the relationships as well. So we'll work on the relationships and the dependencies that we have amongst those as we work into the solution space, and we won't worry about that as a problem space concern. So you saw my diagram earlier that had all the packages. I didn't draw any lines between those packages intentionally, right? they were all part of the overall bookseller domain, but each one of them was separate in and of themselves in the problem space. Now, as we excuse me, as we work our way through to the solution space, then we'll start to worry about and to model how those connections and dependencies and relationships need to be addressed. So, what's the relationship between a domain and a context? Right? Quite simply, domains are the problem space things. You should not ever include any implementation details. Right? You simply want to describe everything from a business perspective in your domain. Quite frankly, many times the solution might change, as the problem space remains relatively stable. Then again, the problem space could wind up being somewhat volatile. So, you may need to address things like GDPR or other kinds of security or personal identity concerns in applications where you didn't have to before. And so those new problem space things that I need to worry about. In any case, no implementation details should be a part of your domain. The context, however, right, are things that may well include details like systems and integrations and databases and other kinds of organizations or implementation level details. Right? Many times we can defer those decisions to a later state rather than up early in the design stage. But sometimes it's we know where we're going to get our data from, or we know what we have to integrate with in some cases, what services we may need to employ, etc. Right? So when I map a concern or a domain to a context, right, in a greenfield application, then I wind up with a very close alignment of things. When I have to take some sort of a legacy monolith into consideration, then there may be a more complicated get that word out, a more complicated context and domain mapping, and so the alignment may not be as readily apparent or as useful or as appropriate as we would like them to be. So when we bound things, right, subdomains are mapped to what the domain-driven design calls a bounded context. And bounded means that the ubiquitous language is associated with that context. There is a complete ubiquitous language that is defined for that bounded context, driven by, of course, the subdomain descriptions and stuff. So within a bounded context, I'm going to have multiple kinds of components. We'll actually talk about each of the various kinds when we start talking about the tactical design, because we're still on the strategic side of domain-driven design. Okay, but whatever's inside that bounded context needs to have a specific purpose related to the context. And then there are various ways that have been defined that allow us to relate one context to another. We're actually going to talk about each of the more common mappings that may occur between bounded contexts. This is somewhat architectural in nature and somewhat of a design in nature as well. So we're doing the Grady Booch thing. All design is architecture, or all architecture is design. Not all design is architecture. So it should be possible to create a unified model within a bounded context, right? Which, as we said before, a unified model over a large organization or even a large department may not be possible. So within one of these bounded contexts, if we've decomposed our domains into subdomains correctly, then we're able to have a unified model that describes how that bounded context is going to work. So here is the mapping, right? So here I've got from my bookseller domain, right, that was our core domain, and we subdivided it into 6 different subdomains, right? And so now here we have a subdomain that is mapped to a bounded context. Now they both have the same name, right? They don't have to, but it's kind of an implied mapping if they both have the same name, as long as they are maintained separately, because the contents of the subdomain book ordering have that problem space description of what the business benefit is going to be, and the bounded context content is going to be the software design, the tactical design, if you will, of the domain-driven design. So in a greenfield development, this mapping is predominantly one-to-one. You can think about a bounded context this way. Think about it as a miniature application. It contains its own domain, its own code, its own persistence mechanisms. There should be some sort of logical consistency within that bounded context. And each bounded context should be relatively independent of any other bounded context. Now, there are some exceptions to that, and we'll talk about them as we work through. But for those of us that are fortunate enough to work on some greenfield kind of development, we can do this with relative ease. For those of us that are extracting things from a legacy application, or combining things from 2 different legacy applications, we have some refactoring to do, and perhaps multiple steps where we only need to do one in the greenfield development. So in order for a bounded context to be considered independent, right, then it should have its own application, its own executable code. It should also have its own development team, right? It should have its own repository. And the capabilities that it develops, the capabilities that it provides, should be provided to or exposed to other applications or other bounded contexts to use in a consistent fashion, right? So somebody can ask me for the answer to a problem, or somebody can provide a piece of data, or depending on, or do some other, ask me to perform some kind of a calculation, or some kind of preparation of some kind of document, or all of those kinds of things, whatever that happens to be. Okay, the context, the capability to perform that behavior should be part of the bounded context API. The relationship then between the bounded context is the problem is described in the subdomain, and the bounded context describes the solution. But life is never that simple. Okay, there are there are issues of what if they overlap? We've mentioned this already one time. What if I've got two bounded contexts and they refer to the same thing, or at least they use the same name, right? And so one of the more common examples, of course, is customer, because customer tends to be involved in a lot of different things in our any kind of retail or customer-facing kind of business. So we ask ourselves the question: are both of those bounded contexts referring to the same thing? Right? If our analysis shows that nope, they're defined differently in different domains. Right? So they're in those domains. The ubiquitous language says, they're defined differently, although we use the same name. That's okay. We'll continue to use the same name, right? Because it's part of the ubiquitous language for that subdomain, which is mapped to some bounded context. And so using the same name, if we have two different development teams, we say, well, we got our own development team. So our own development team has created or collected up or has available to them the ubiquitous language for that bounded context. All right, then I don't have to worry about what is it in some other bounded context. However, the more likely, not more likely, perhaps the issue that causes the bigger problem is the answer is maybe. Okay, the item seems to refer to the same thing. Right? Then I have to figure out what to do. Right? If it's no, we're okay. If it's maybe, then I may need to share that object, and there may be I may have to figure out who owns the object. I may extract that object and have some sort of shared object. There's a number of different ways that I can address this, but the fact of the matter is it's certainly more complicated than the no answer. So one of the ways that we can address the maybe question, or the maybe answer anyway, is through the utilization of context maps. Right? So domain-driven design has this notion of, well, if I've created a bounded context, and I know what its responsibilities are, and I know what some of its behaviors are, and et cetera, I know what kinds of information it might need from some other piece of or some other bounded context, and the context map is what I use to describe how those different domains relate to each other. Right? This includes things like I'm going to provide a service, and you're going to use that service, and we're going to do that through the well understood and published API. So we call the contexts bounded contexts because each domain has a boundary. Right? So we're not as concerned with what's inside the boundary. Right? Whatever the components are that are being used to perform the operations that are available from that bounded context, whatever those services are being used by other applications, et cetera, are implemented in a way that I don't care. Right? I don't care what the language is. I don't care how the model inside the bounded context is actually formed. All I care about is what is at the boundary and what services are being exposed for use by other applications, and what mapping I'm going to need to employ in order to be able to utilize that information. Now there are several mapping types, and so we're going to look at 8 of them. These are the 8 most popular, if you will, starting with partnership and ending with big ball of mud. And we'll look at each one of these mapping types individually and talk a little bit about when you might use them and when you might need to look elsewhere. Okay. So each of these describes a way for one bounded context to use the services or provide services to another bounded context. So partnership, the first of the 8. And so there's some sort of mutual dependency between 2 bounded contexts. They need to work with each other. They may call each other's interfaces, etc. If we've done our organization in the not prescribed but suggested manner, okay, then I have 2 different development teams, and they are each working on their own bonded context. But because of the heavy mutual dependency, they need to actively cooperate. Active cooperation may involve things like having mutual or a single release date for each of the bounded contexts as they're updated. So this is one of those situations where we're kind of we're not following the example of, hey, I want to be able to deploy this independently of others. These 2 bounded contexts need to be deployed together, and together it needs to be done in order to keep them from breaking one another. Truly speaking, this kind of tight coupling should only be employed when other types of mapping won't work. And so hopefully your designs will be limited in terms of partnership mappings. But there are many times where you're working through the replacement of a legacy system where this kind of relationship is actually essential or required in order for you to be able to start to break things apart, right? Because things don't necessarily tease apart as nicely as they might in when you start out working trying to make them independent in some sort of a greenfield development. So the next mapping type is a shared kernel, and so a component or a piece of data or a service is used by more than one context. Okay, and so because it's the same, the answer to our question of is it the same is yes. Then the 2 dev teams agree that we need to extract the resource into its own bounded context, and then share that between the 2 dev teams. The shared resource then is only changed in coordination with the using the dev teams. Okay, if the resource is fairly volatile, this doesn't work very well, and so it works best whenever you have something that's shared rather than something that requires frequent modification. But if the data changes but the API does not, then that's not a problem. Okay, and so if the data changes weekly, that's not a big deal because the actual deployed kernel is not going to change. Again, the shared resources is its own project, its own bounded context, and it may be owned and worked on by one or both of the teams, depending on how you have the the coordination set up. Okay. This kind of thing is often some sort of cross-cutting concern. So cross-cutting concern includes things like authentication, authorization, logging, that kind of information about that cuts across multiple bounded contexts. And so, I don't want to have to put login in all of my bounded contexts. I want to share that authentication kind of information with a single well-constructed, well-maintained kernel or its own bounded context. And the same goes for just about any other cross-cutting concern that you might encounter. The next mapping type is what we call customer supplier, and in this case, one context supplies some service that's used by some other bounded context. Right? So we have one that's one context that acts as a server, as the supplier, and one as the customer, and the two teams, work together to define the interface. And with any sort of luck, they also have acceptance tests that are run in order to validate the interface. And so, if one side makes a change to the interface, right, then the test should fail, and it will alert us that we need to do some work. Right? So the supplier team, okay, can do whatever they want to refactor their service, as long as they don't change the user interface, whether it's a graphical user interface or more likely some sort of API. Okay, and when the service interface is changed, then we have the notion of failing tests, or we now have failing tests, and the customer service or the customer bounded context is now required to do the upgrade necessary to make the test pass. A conformist says one bounded context supplies some service that's used by another bounded context, just like the customer supplier. Unlike the customer supplier, the team providing the service says, here's the interface and I don't care what you need. All right? Whatever, get what you need from me so that using whatever it is that I provide, and if you don't like it, tough. Right. Well, now that would be an unfortunate kind of response from a development team within the same organization, and so that would probably not happen. But what will happen is that I've got some legacy service that can't be changed. I've done things in the past where we've had executable modules, and they're so old, or they came from some other source, and nobody even knows what the source code is. Right? It does the math necessary, but it doesn't work. That happened to me once when we were working with a bunch of safety kinds of calculations for weapon systems, and it's like, that piece of software has been validated and verified, and we're not going to change it. So whatever you need to do needs to conform to whatever it is. And so the rest of our application, the rest of our bounded context need to be concerned about how to work with a fixed set of APIs. In this case, the difference between this solution and the next mapping that we're going to talk about is that we don't have any kind of translation services. There's no sort of interface between one and the other, but the consumer, for perhaps performance reasons or some other kind of reason, actually makes changes to their code to conform to the supplier's interface. On the anti-corruption layer, so the consumer says, no, that part about making changes to my model, making changes to my domain are not acceptable. And so I can live with the performance issues or whatever they happen to be, or the potential security issues, or any of the other concerns that I might have, in being able to set up a separate translation layer. We call this the anti-corruption layer, in part because it means that I'm not corrupting my domain model. I'm keeping my domain model pure, and keeping the potential corruption out there at the interface side. Right? So I act as some sort of a buffer between the two systems, and there's multiple ways for us to implement the anti-corruption layer. So there are a couple of design patterns that we may choose to employ here. It might be the facade design pattern or the adapter design pattern, where we may do a one-to-one translation, or we may do a many-to-one kind of translation, or a one-to-many kind of translation, depending on which way we want to go. So as we can make one single call into the anti-corruption layer that may result in 2 or 3 different calls to the actual domain model. So we don't corrupt the customer domain within our bounded context, and so it's the anti-corruption layer implemented in a couple of different ways. So the open host service is an interesting concept, okay? So this is, I've got service suppliers, and these service suppliers may have multiple customers, right? So there's perhaps too many, or an unknown number of folks or bounded context that I need to be concerned with or concerned about, and how do I affect them? And so the service supplier defines a protocol that allows access to their system, and then I provide that to anyone who wants to use it. Teams may request changes to the protocol, but not all requests will be honored. You know, perhaps a change requested by one team could result in breaking something for another team, and so we may employ some sort of translation service like the anti-corruption layer in order to, along with that open host service. Okay. The reason that we would want to do this, other than the translation service, like the anti-corruption layer, is that could be a performance issue, or it could be just an issue with the various dev teams. Okay, every time I add a translator, there's more code to maintain. There are more interfaces to maintain. There are more places for things to go wrong, and so, and especially more places for things to go wrong when I make changes. And so providing a standard protocol is a useful way to do that. Anyone who, you publish it, it becomes public. we expand the protocol as necessary, and then only do translation when it's absolutely necessary. Separate ways is easy enough to understand. Usually it's an issue where we have been cooperating, but we don't know why, or our reasoning for being able to share some resource was faulty, and further analysis or experience has shown that we really don't need to work through any kind of integration because we really are separate bounded contexts, and so we make a decision to break apart and go our separate ways. The most common time, or the most common issue is usually related to some sort of database, especially where one party decides that they want to go to perhaps move away from a relational database and go to a more modern database for like one of the NoSQL kinds of things, and so in any case they can use their own repository independently of each other, and so we go our separate ways. And then one of my favorites, okay, the phrase "big ball of mud" was introduced into the software vernacular by Brian Foote and Joseph Yoder in 1999. They wrote a paper that was intended to examine the most frequently deployed of all software architectures. That is that it was a big ball of mud. And what happens is your legacy applications are often so intertwined and so complex that you really can't separate out the individual bounded contexts. All right? So when that happens, the boundary becomes the whole mess, whatever the mess is, the legacy application, and nobody thinks big ball of mud is a good thing. Certainly interfacing with such a system can be challenging, and your own, whatever your bounded context interfaces are going to be probably more scrutinized or more challenging when you're trying to interface with this big ball of mud. Okay, finally, the other way that we tend to have some integration is that we have two bounded contexts using the same table or at least the same database. It certainly is not does nothing for defining the boundaries between the two contexts, and often serves to be, a fuzzy kind of thing. Certainly, the interface between the two can be modified, somewhat unintentionally if you're changing the database or doing some separation of things. Often, once I've made the change to actually do the database read, I might not document it, or it might not be modeled correctly, or whatever. And this is certainly not a recommended method for integration between two bounded contexts. It may be tempting to do that. Okay, let them use the same table, but it's safer, much safer, to let each bounded context have its own database and to design some sort of specific mapping based on all of the ones that we just talked about. And if it is truly, I need the same table and I need the same data, then the prescribed mechanism is don't just share the repository, create your own project and create a shared kernel mapping so that there are a well-defined API for accessing and doing whatever needs to be done with the data. So here is a context map example derived from our bookseller application. And so in our subdomains, we had inventory and book ordering. Our analysis goes through as we create the bounded context and says, well, both book ordering and inventory have this dependency upon a book titles database or a book titles repository of some kind. And it turns out when we asked the question of, is it the same? The answer came back yes. Right? So we extracted the book titles into its own bounded context. Right? Now, there's no mapping between this bounded context and any of the subdomains. Right? The subdomains, there is no book titles subdomain in our problem domain analysis. Right? So this becomes a solution space artifact. A software design artifact that that we start to employ. All right, and so both inventory and book ordering are mapped to the book titles through a shared kernel mapping. Now, as we move a little bit further through to our design, okay. There's a lot of information that we can keep track of, or we can add to our strategic design. So here we have the same inventory and book ordering contexts that are using the book titles by way of a shared kernel mapping. We've specified some requirements for the inventory, and we've specified some requirements or stated what these things are going to do, right? So this is kind of like a high-level design where we know we want to create book orders, okay? We know we want to maintain a list of booksellers, et cetera, and we're going to receive books into inventory, remove books from inventory, and so each of the references to books in those two things accesses the list of book titles being maintained in the separate shared bounded context. So there's kind of the end game of a strategic design, right? And so now we move into this notion of tactical design. And so if you were in a an old mill standard kind of software development or waterfall kind of development approach, you might say that we're going from the top level design to the detailed design or something of that nature. But we're actually taking this strategy that we've created in terms of bounded context, and now we're going to move into the solution space at a deeper side. So there are 7 different building blocks for using tactical design into the domain-driven design paradigm. Okay, there are 4 of them associated with the domain side of things, and 3 associated with service. And I'll explain the difference between these two. Okay, so we'll start with the aggregate. Okay, and that is the collection of objects bound together by the entity we call the aggregate root. Okay, and so, for example, an aggregate might be a purchase order. Now, each bounded context has at least one aggregate, and may well have multiple aggregates, depending on what its trying to produce. Okay, but if I had a purchase order aggregate, right, it might have a set of objects associated with it. Right? There's some deletion semantics that go along with this, which says that an aggregate owns the stuff that that it connects to, and so therefore, if the if the aggregate is deleted, then it makes sense that all the things that it owns or is related to ought to be deleted as well. When I access the data that's being held by the aggregate, no matter how it's being held, right? It should be through the aggregate method. So the aggregate provides, part of the interface between a bounded context and the outside world. So each of the aggregates within a bounded context provides a set of methods that is public and accessible and provides services or seeks services from others. And just like in a good object-oriented design, then none of the members should be accessed directly from outside the aggregate. You want to maintain the state of the aggregate by accessing everything through the methods or the operations of the aggregate. And so here's an aggregate for purchase order. Okay, and the purchase order, we haven't talked about them yet, but we'll get there, has a relationship with 3 different value objects. Okay, a purchase order ID, a date, and 1 or more line items. In addition to that, I've got some business rules that are specified for the purchase order, that it has to have at least 1 line item. It can't be processed without a signature, and the signature must be a director if the total for the purchase order is greater than $1,000. So now I've got some things that I can test against. I have some things that I can use to incorporate the methods into my purchase order, and I can literally do some software design. And so now here's where the notion of models starts to blur a little bit. If I take this as is, okay, and put that into Eclipse or Visual Studio or whatever my IDE is, right, and then add the code necessary to, for example, implement those business rules, etc. Am I still developing a model? Right? I'm going to tell you yes, that the model doesn't have to be this graphical representation completely all the way to the end. Right? So use the tools that are appropriate. And as an aside, one of the things that I might do when I got to this point in a design is actually use an IDE because most of them are in some way better suited than most of the modeling tools for adding the kinds of information, those wizards and shortcuts and other kinds of things that we can utilize. But I then go back, on a routinely and go back to the modeling tool with the code and update the model in the modeling tool with the code that I developed in the IDE, and this, keeps my graphical model up to date, is relatively painless, doesn't take a lot of time, but there's something to be said for having a graphical representation that one can refer to during discussions of changes and other kinds of trying to understand what's going on rather than trying to read your code line by line. So entity objects, right, are things that are relatively long-lived and have, as it says here, stable identities, right? So if I have a person or a customer or an order, all of those things have fairly stable identities and fairly stable lifetimes, right? One of the things that I know about each one of these things is that they have to contain some kind of ID, something that keeps them identifiable from the other. Right? So a stable identity is something that remains the same, that provides some continuity, right? And so multiple processes or multiple executions, etc., can be executed, and the identity is maintained. Okay, the primary responsibility of an entity is to provide that unique identity and to implement equality checks. And so hopefully the identity of an entity is consistent and constant throughout its lifetime. Now contrast that with a value object. A value object is an object that's defined by its attributes. An entity is an object defined by its identity and not its attributes. A value object is defined by its attributes and not necessarily by its identity. Right? So I'll try and give you an example of what the difference is. Right? If I go to the movies, I get a movie ticket, and the ticket tells me what movie I can go see, and perhaps the specific date and time that I can go into that particular movie. Right? If two of us go to the movies and we each get a ticket, right, and then we exchange tickets, there is no difference. Okay. If we get our tickets mixed up, there's no difference, and I don't care if you have mine and I have yours, because they both have the same value. They both have the same attributes. On the other hand, if I go to, let's say, a show in Las Vegas, okay, I get a ticket. Right? That ticket has a date and a time. It has some attributes, but it also has a seat number. Okay. If we mix up our tickets, then there's some differences there. Right? Your seat might not be as good as mine. So the value objects, right, are things that can be shared, things that are thin and simple, things that they can pass by value, whereas an entity has an identity. Okay, it can have attributes. Like the movie ticket does, okay, but it also has an identity, right? So if I have a ticket for a specific show on a specific date, sitting in a specific seat, the combination of those three things provides the identity for my ticket. A domain event, right, is something that has happened, right? And so you see in the examples down here where we have order completed, item shipped. Right? In domain-driven design, we try to name our domain events with a past tense name. Now, quite frankly, I don't always or even often append the word event to my event names. They're usually fairly well understandable without appending the word event to them, but there's certainly no great harm in doing that. But in each case, all right, the examples show something that has already happened, all right, and having happened, all right, there is a date and time of when that event occurred. So what I would like my domain events to have is not only the date and time that it occurred, but the identity of any entities involved in the event, such as the identity of the entity that generated the event. And so we have the notion of firing and then collecting up an event, and based on that event, taking some kind of action. Right? So that action tends to come in the form of a publish and subscribe kind of relationship, right? Where one bounded context publishes the event that's generated by one of the entities that's contained within that bounded context, right? And some other bounded context is waiting or interested in that event happening, okay? So if the order processing system publishes an event that says an order has been entered into the system, okay, then the warehouse processing system, the warehouse processing context is interested in receiving that event, right? And based on the reception of that event, begin the process of putting the order together based on the data that's being conveyed by the event. So there are a number of ways for us to do publish and subscribe, to do messaging. The one thing that we're not going to do is probably do any kind of sophisticated complex ESB kind of thing. We'll do dedicated messaging between our bounded contexts. The domain events are asynchronous, right? And so what this means for us is that we have loose coupling, right? So for those of us that went to school, we find out that loose coupling is good. You know, high cohesion within elements is good. And so the bounded contexts give us the cohesion, and the events enable us to minimize the coupling between the various bounded contexts. So recall from our chart, right? I will remind you. One more, okay? That aggregate, entity, value object, and domain event, okay, were the domain building blocks. Now we're going to jump over and talk about the service building blocks, being service, repository, and factory. Whoop. So what happens if I have a behavior, right, and I don't know where it belongs? No individual, aggregate, or entity or value object should own that behavior. Right? It is a system-wide behavior, or perhaps you know, something that is spans multiple kinds of bounded context, etc. So we have the notion of a service, okay, and so they have services have interfaces, and services implement behavior. So we have some rules for when we create a service. A service should make sure that you should make sure that the behavior does not belong to something else. Right? It should be in the same domain or layer as the object it works on, and it should be implemented in a stateless fashion. In other words, it should be every time I execute that service, it's in a consistent state, and it ends in that same in a consistent state. I don't subsequent executions of the service do not depend upon previous executions of the service. So what you don't want to do is start to package up all of the behavior in your bounded context in services and actually taking it away from entities or value objects or whatever. Entities and value objects that don't have the appropriate behavior are often called anemic. And we don't want anemic models. We don't want an anemic model. We don't want an anemic model in our development effort. So here are some examples of what we might choose to implement as a service. So for example, an invoice number generator or a meeting scheduler or a conflict detection service, okay? Any one of these domain services is, the domain logic doesn't fit into a single entity. And so it lives inside the domain layer. It does not communicate with the outside world, right? It's a service that's being used by the single bounded context. An application service, so that handles some sort of workflow or application flow and typically delegates some kind of operation to the domain layer. They are often used by or part of the interface to the outside world, possibly a presentation layer or something of that nature. And so they are the conduit that gets us into the domain model. And then there are the infrastructure services. Right? So things like, event email sender. And, sending an email is obviously an infrastructure service, and I don't want to implement that in multiple bounded contexts. So I use that in a service that does not belong to an individual entity or object. The repository, we call it a repository because it might not be a database. The repository might be a flat file. The repository is whatever makes sense for my aggregate root. Mm-hmm. So there should be a separate repository for each aggregate root, which essentially, if you recall, we talked about having the potential for multiple aggregate roots within a bounded context. So a bounded context may have multiple different domain object repositories, the different persistence mechanisms. The repository interface itself will take care of retrieving all the aggregates and adding aggregates or individual collection aggregates, either retrieving them from the data or updating the data or adding new ones or all of those kinds of things. Examples for what we might be doing include things like the Java persistence, the JPA that allows us to abstract away from the persistence operations from the persistence mechanism. Finally, factories. Okay. Now, factories are used in domain-driven design to create aggregates, entities, and value objects, right? And so we separate the creation of an object from the object itself. So instead of using the language features for creating elements like saying new aggregate or new entity, we create this notion of factories, right? And so the factories are useful in creating an aggregate because it will encapsulate the knowledge that's required to create an aggregate in a consistent state and with all the invariants enforced, right? And so the names of the factory methods can be more explicit than new, and they can oftentimes, when an entity of any kind or a value object has complex construction requirements, then we can construct those objects and encapsulate the logic required. And in fact, there are times where if the construction of the object has some complexities, then as we finish with an object, we might be able to reuse that object with a new set of values. This is more often done with value objects than for anything else. But I can create a new value object fairly simply with a factory. But what if it's a complex value object? Then if I reuse the old one with a new set of values, I may save some time and effort. The other issue is that I can, when I say new in my code, I get one kind of thing. Right? A factory may be able to return objects of multiple types depending on how I've got it implemented. And again, this is we're not introducing anything new in the world of patterns here. All the patterns that we've talked about so far are things that were described in the original Gang of Four design patterns book. And there's lots of documentation on how factories work, or how the various adapters and facades work for the anti-corruption layer, et cetera. Okay. So, what does that mean to microservices? Why is there such a strong relationship between the process or the approach, the software development style of DDD and this somewhat new phenomena called microservices? Well, we talked about some of the ways that the DDD and microservices are related. Okay, so in domain-driven design, we talk about each bounded context has its own dev team. Okay, and each aggregate has its own repository, and when we do our domains and then map them to our bounded contexts, and then extract the common items, etc., we're working on a desire to create this separation of concerns. Well, if you go turn around and look at microservices, that's pretty much the same thing. Okay, we talk about having our own dev team. Okay, we talk about each microservice has its own repository. That there's a separation of concerns, and so each microservice does one thing and does it well, and then in addition, the microservice is deployed to its own process. We'll talk a little bit more about that here, I think, in a second. But the notion is that it might be deployed to its own virtual machine, but it's more likely to be deployed to a container that's running on a virtual machine. So microservices as bounded context. Right? So a one-to-one mapping, right, can exist between a bounded context and a microservice. And so as we employ the notion of context maps and figure out what sort of relationship exists between the various context maps, right, then we can figure out what the APIs for our microservices might need to look like. Right? And so if bounded context A provides an API that other bounded contexts can use, right, then that means that the microservices will have the need to employ that. Now, there's a couple of different ways that we might do that. one of the most popular, of course, is a RESTful API. And so we use the various tools that enable us to do REST and RESTful APIs, and use that as a mechanism for communication between microservices. But there are other messaging and messaging gateway kinds of things that we can employ and that we can use. And so microservices map one-to-one with bounded context, and the APIs are well informed by the kinds of mapping that we've already done between the bounded context. Now, in the world of microservices, we have the notion of an architecture that's different from the standard layered architecture. We kind of took the layered architecture and then kind of wrapped it around. Now, this architecture was originally called the hexagonal architecture because the first time that Alistair Cockburn drew it, it had 6 sides. And he thought that sounded pretty good to him, so he called it hexagonal, okay? Other people have called it the onion architecture because it kind of wraps around one another, and you have different layers. In a recent article, Cockburn wrote that he wishes he had called this ports and adapters from the beginning, and he stopped using the term hexagonal and started using the term ports and adapters. And so what we have here, right, is that a number of ports, right, in the blue elements here, and we can have multiple adapters that support things like tests or types of users, etc. And so if you look at the REST API, okay, there's a behavior-driven test adapter. There's an Angular adapter. There's an other agency adapter, right, coming from various kinds of places, etc. Right? And I'm not limited to, although the diagram here shows 3 in each port, you're certainly not limited to that. This is just illustrative. Okay. The same is true with event streams, event sources, persistence. So I've got an object relationship map, software development kit of some kind, a mock database, etc. And so if you go over here to the left-hand side, he calls those primary ports. That is the stuff you need to interface and to work with this stuff. Secondary ports are the supporting kinds of things. It is Alistair Cockburn after all, and so it wouldn't be right if he didn't mention use cases. And so the use case boundary that you see here in the gold, all of that stuff is the non-technical use case driven kinds of implementation, etc. The things that can be described or required based on how the user needs to work. In other words, your domain model, which is being informed by your subject matter experts, your domain experts, your business users, etc. Right? The rest of the stuff in the blue, is the technical realm of the software developers. Right? Given that I need to do certain kinds of things within the domain model, then I need to specify various kinds of event streams or REST APIs or persistence mechanisms, etc. So if you look at this with a little bit of DDD, okay, we still have the domain model in the middle, right? The event producers, right? So the event generators, the event listeners, various repositories, and the persistence adapters, the queue adapters, the GUI adapters, and the other queue adapters. So we have we talked about services, right? And services need to be related to the domain, but they're not part of any of the domain objects. And so that's what this is trying to show us out here with the application services. And with the event producers within the, related to the domain model. So the domain-driven design maps very well to this hexagonal or ports and adapters kind of architecture. When we talk about adapters, right, again, that's another well-used, well-understood pattern that was described originally in 1994, right, and was basically used to adapt legacy entities to new development. Right? I used it once where a set of services that was developed using the C++ language was delivered to me, and my user interface was described in Visual Basic. And so in the API for the services, there were things like pointers to pointers, and Visual Basic was totally confused about pointers. And so it became necessary to write an adapter. Right? It was a one-to-one kind of thing. Something from a call to a service from the user interface went to the adapter. The adapter added the pointer C++ notation to it, and then called the service. And then the return went the same way, right? And so we were able to take two things that were developed separately to the same set of requirements by two different organizations, geographically dislocated, and quickly figure out that we didn't need to change either side of the development effort, either legacy, if you will. We took two legacy kinds of things and mapped them together using the adapter. This works the same way, right? Those adapters bridge the application to the service, and you use one adapter for your BDDs or your test kinds of things, and one adapter for the desktop graphical user interface, and one adapter for the mobile user interface that's being, that's an app, and another adapter for some other kinds of interface for doing accessible stuff, whatever it happens to be. Okay, the adapters around there, around each one of the ports, adapts what we need to using the same set of service names and the same set of operation names, but different behaviors within them based on what we need and what we're connecting to. So when we map all of that to microservices, okay, all right, the microservice boundaries are now based on business capabilities. They're not based on size or any other kind of mechanism or mapping kinds of things. All right, so we've got a single microservice for an area where there are a high number of dependencies. Now, this should sound a lot like a bounded context. All the stuff that's a part of that bounded context is related to one another. They have a high number of dependencies inside the bounded context and a small number of dependencies outside of the bounded context. Right? The same thing is true of microservices. So defining that bounded context then allows us to create that microservice implementation. We are able to take the DDD context mapping pattern and say we have these 8 or 9 different ways that we can map one bounded context to another. This enables us to identify how our microservice context are related to one another. And so if we have a one-to-one mapping between a bounded context and a microservice, then we have a one-to-one mapping between the relationship between those services. And so there are a domain model with all of the kinds of domain entities or incorporated into and applied to any kind of a microservice. And I know that the boundaries are right, when there are few strong relationships between the domain models. And I don't need to merge information from multiple domain models or from multiple microservices when performing typical application operations. So the notion that domain driven design is a very popular and ongoing way for us to create our microservices. So finish up with a microservice should run in its own process. Now, at one point in time, early in the microservice world, that meant a microservice per VM. Now that's somewhat wasteful on a number of aspects. So first of all, a VM it takes some time and consumes some resources in order to spin it up. Okay, and so there is, generally speaking, wasted resources within the VM when it's only running a single microservice. So, so we came up with this notion of containers, and so a microservice winds up deployed to a container, which is a much more efficient way to deploy the microservices. And then multiple containers can be deployed to a VM. Now, there's efficiencies here because it doesn't take anywhere near as long to spin up a container as it does an entire virtual machine. And so, and the resources of a virtual machine can support multiple containers. And so I don't have as many virtual machines as I have microservices. I have a smaller number than that. All right. In each one of these things, okay, the microservice is represented by a bounded context. Right? And so the microservice or bounded context per container has its own repository, has and can possibly communicate with other microservices in a well understood and well documented fashion. So the takeaway here is that domain-driven design gets IT solving the problems of the business with everyone speaking a common language. The whole notion of a ubiquitous language is terribly significant. It's not, totally new. Years ago, doing object-oriented analysis and design, we often started with what we call the domain or a conceptual model, right? Which said, here's the elements of the problem domain, and here's how they're related to one another. We've taken that a step further with domain-driven design and specified some unique mappings and in the context map, and then a unique implementation using aggregate roots, entities, and et cetera. All of that is virtually a one-for-one mapping to the development of microservices. So if you are going to engage in the development of microservices and deployment to containers and management with Kubernetes and all the various things that might happen here, then the notion is that domain-driven design will get you there in a very elegant fashion. I want to call your attention to a couple of upcoming classes. They are two on microservices, developing microservices, general, and then microservices development in the Windows platform. And so I know I mentioned Java or JPA, but certainly there's no requirement for any of that to happen, exclusively in Java. It can be a .NET thing. It could be, a number of other implementation languages, etc. And so there are some upcoming classes that you may wish to explore. And so I will open the floor to questions. And hopefully Carling is listening. What do I need to do to? Okay, so all right, I'm trying to. There must be a way in this to do this. If you do have questions, okay, if you can type them into the chat window, that would be useful. While I don't. Let me see if I can. No, I got a button to mute everybody. That's not what I want to do. Okay. Well, I can't call her. All right. So I got one question that says, how is domain-driven design and microservices related? That came in very early, and so I hope I answered that one. So let's see. So the notion of context for which different concurrent versions need to exist, as long as there's a different identity, right, then there should be no issue with deploying services with multiple versions in multiple different containers, as long as there's a way to identify the different versions. No, there's not going to be a break. So my name is J.D. Baker, right? And I am, so let's see. All right, so the next question has to do with a way for us to communicate, okay, and using microservices. He mentions ESBs, right? Well, I will start by saying that for the most part, the ESB is not necessarily well liked in the world of microservices. So let me, let's see. So there's a number of things. They have this notion of what we call ESBs, and I was looking for the way that we do that. But anyway, so there's in-process methods, so that the mechanism can be as simple as some sort of remote procedure call. The other kinds of communication mechanisms include a RESTful API. One of the mantras of domain-driven design with respect to microservices is the notion of smart endpoints and dumb pipes. So minimizing coupling between services. Let's see. There it is, okay. So microservices see an ESB as an egregious spaghetti box, which I thought was an awfully interesting quote, okay. But it is not the recommended mechanisms for doing the interconnectivity. The most common and the most widely used is the notion of a RESTful API of some kind, and there are oops, that isn't going to work. And so there's a number of different messaging mechanisms that are, all right. So the next question is, what's the difference between SOA and microservices? Well, probably the biggest difference is that the service-oriented architecture is a little bit challenging, and in part because many people still don't know what a SOA is, right? But they are considered in many circles to be just a subset of service-oriented architecture. Some microservices are infrastructure related, and in that respect, SOA's primary focus relies on business service, and the one thing that seems to be common between the whole world of SOA and this notion of microservices and things that can be deployed to containers is the notion of breaking up monolithic applications and decomposing them into smaller chunks of functionality. And so, beyond the fact that microservices shuns the notion of the ESB, there's if that's your backbone of your SOA implementation, then that will be different in the microservices. The relationship between a microservice and an application. Well, a microservice is part of an application. Most of the time, there are some set of bounded contexts which map to microservices that taken together form an application. And that each one of the individual elements, each one of the individual services can then be replaced or duplicated as necessary, right? And so the overall application consists of multiple microservices. This notion of well, there isn't a, certainly I can deploy to the cloud, right? So the notion of, you know, how does it apply to the cloud and containers and Kubernetes? So Kubernetes is a management tool for your containers, and so, you know, if you have some combination of Docker and Kubernetes deployed somewhere, and I don't care if it's AWS or Azure or your own personal cloud or whatever, right? The infrastructure for where those services are running is not as important as the creation of those services. The notion of reusability in DDD model. Well, you know, it depends. Okay, so as the you know, each one of those models, right, is related to a subdomain, right, and so as the business problem changes, your model is certainly possible to reuse, but because they are intended to solve a unique business problem and address, you know, a specific ubiquitous language, often there's not as much reusability as we might like in all of those. Yes, typically multiple microservices make up an application. It is, in my experience, the question was, can all microservices use the same DB? The most common way to deploy a microservice into a container is with its own repository, whether it be a database or whatever the other repository is, all right? And that each one of those, each microservice has its own unique, different kind of element, okay? That each one uses its own unique repository, you know, within its own container. A somewhat complex question, so that you know, what do I do about nested objects? Okay, where the aggregate root is something like a car, and then, you know, that decomposes and decomposes and decomposes. There's yeah, that's an interesting question. And you are right that IDs are you know, a useful mechanism for being able to traverse that, but at some point in time, you know, it may well be that you know, how do I break that up, okay, into different bounded contexts, and so do I have a single bounded context that is the car, and then a bunch of aggregate roots, and then, you know, entities from there, or do I have a number of bounded contexts that come together in the bounded context of the car, the overall car? I honestly don't know which approach I would take. I guess it would depend on the particular problem. How can we compare it with procedural design? Well, it's different. It is, in many cases, you know, once you get down to the actual implementation in the aggregates and what have you, there's certainly no reason that you can't implement that with, you know, a procedural language or a functional language, as opposed to I was trying to read the next question and I lost my place. So as opposed to the object-oriented stuff that we showed in the slides and that. Okay. I'm sure that everybody who registered will get a link for the recording, and I'm reasonably certain that that I don't know how that's going to happen, but there will be a recording, and there will be a PDF of the slides will be available as well. So a relatively complex question about microservices coexisting with SOA strategy in the same organization. And I think that part of that has to be with where is the legacy, where is the migration going to take place, where do the boundaries exist between the different kinds of services that we're trying to implement, et cetera. So it is possible. Notice that one of the things that is typically talked about is this notion about separate dev teams for each microservice. And so, you know, if we have different dev teams for SOA and different dev teams for microservices, then we have a communication kind of thing. Are you this J.D. Baker? Yes, sir, I am. And well, certainly the next question was, would an API manager be better suited to microservices than an ESB? Yes, okay, is the short answer. Most of the time, ESBs are just a little too heavyweight to do that. So recommendations for a synchronous approach. Just a minute. Yeah, no, let's see. So there are some lightweight messaging systems you can use for asynchronous communication. They include things like RabbitMQ. There are some wire level protocols such as AMQP. AMQP, I always forget what that acronym stands for, but that's a standard that was a wire level standard that was created by the financial industry in order to be able to do messaging, and so that that may well be a useful thing to do. So bear in mind that what we're doing here with microservices is we're only routing the messages. Remember, smart endpoints, dumb pipes, and you know, the processing tasks are done with the services, et cetera. There are some techniques for non-blocking remote calls, like WebSockets and other methods of reactive computing or reactive programming. So any of those might be useful for you know, an asynchronous approach. All right, so REST is an API description mechanism, right? And so no, it's not a service, and it's certainly not a microservice. It is an interface description technique based on the HTTP protocol. Oh, and so the last question was, can we do things like lazy load, you know, and update state, you know, after construction? And certainly, yes, absolutely. There's no reason not to do those kinds of intelligent infrastructure-related kinds of things as well. Well, I guess before I do another one of these things, I need to figure out how to enable people to unmute folks. But thank you for those of you that added questions into the question panel. And I'm going to drop off now. And okay. Oh, I have been to an OOPSLA or two. So thank you very much for the comment. And we'll look forward to seeing you guys next time around. All right.